Hello, today I want to look through a typical practical that can be used to show the percentage of oxygen in the air. There are a number of slightly different practicals that can be used to show this percentage, but they're based on very similar principles to what we're going to see in this practical. Right, so this practical involves the use of iron wool in this conical flask. Right, it could be iron filings, but in this case it's iron wool. So we've got iron wool in a conical flask, we've got a connecting tube, and we've got a gas syringe connected to it. The basic principle is that we're going to heat up the iron wool. The iron wool will react with any oxygen that's in the air surrounding it, and that will reduce the volume of the air by how much oxygen has reacted. So you will have to do a little bit of maths in these questions, and they might give you a few details. So for instance, if I'm going to add some quantities to this particular practical, they will tell you the volume of the conical flask. So it's 100 centimeters cubed, could be anything else, I've just picked 100. You've got a connecting tube here, and I'm going to say that this has 10 centimeter cubed capacity, and then I've got a gas syringe. And you need two values for the gas syringe, so what I'm going to give here is the start volume, which we'll say is 100. So let's say it's 100 centimeter cubed capacity. So in total there, if I add 100 centimeters cubed from the conical flask, 10 centimeters from the connecting tube, and 100 from the gas syringe, that is a total of 210 centimeters. So that is the total volume of air that I have in this container that the iron could react with. Right, if we let this react, the iron will react with the oxygen in the air. We don't know how long that's going to take, and they will give you a quantity. So at the end, the syringe may have moved, and it has a value of 61 centimeters cubed. So we now have an initial volume in the syringe and a final volume in the syringe. So you need to do a simple calculation, which is initial minus final volume, which is 39 centimeters cubed. So that is how much oxygen has been removed from the air. So remember, the iron wool reacts with the oxygen to make iron oxide. That will therefore reduce the volume of the air that's in those conical flask, connecting tube, and gas syringe. So the calculation we need to do is how much of that air was oxygen. So we know there was 39 centimeters cubed of oxygen, and we know that the total volume was 210. So we just need to do 39 divided by 210, and then because we want it a percentage, we'll times that by 100, and you should get an answer of approximately 18.6%. Right, and that is less than the amount of oxygen we know is in the atmosphere, and that's quite typical of exam questions, because they want to start thinking about why you don't get 21%, as you should do, because the volume should be slightly larger. Another thing I should have pointed out is that the iron wool is generally in excess, and that means we've got enough iron wool to react with all of the oxygen that was in that tube, so there shouldn't be any oxygen left in the container. Also, we need to leave this a sufficient amount of time, so if you don't leave it long enough, not all of the reaction will be complete, and therefore all of the oxygen will not be removed. So these are the typical kind of things you're going to get asked. I could have done this with iron filings. I could have done a similar reaction to this with copper, because the copper will react with the oxygen as well. And another experiment that we do is with phosphorus. So you can have phosphorus reacting with the oxygen, and it will reduce the volume of the air. So they all work in a very similar way. They reduce the amount of air that's in the container, and you work out the difference. That's how much oxygen was in the air to start with. And that's it. That's a very common practical they will ask questions about.